All right. Again, the formula for response resonant or the R is the square root of 1 over beta times Rn times Rh times Rb, quantity 0.53 plus 0.47 RL. This is from the equation 207A.9-12 from the first printing of NSCP and 916 from the second printing of NSCP. Okay, now your Rn is the resonance factor for N. Okay? And our Rn is equal to 7.47 N sub I over 1 plus zero point 0.3 times Ni raised to 5 over 3. Okay? So this is from equation 207 A 0.9-13 of the first printing and 9-17 of the second printing. Okay? Now, in which Ni is N sub 1 times L sub Z bar over V sub C bar. Okay, now this is from equation 207 A 0.9-14 from the first printing and 918 from second printing. So our V sub C bar is equal to V bar times Z bar over 10 raised to alpha bar times B. So this is from equation 207A.9-16 or 9-20. Now, where B bar and alpha bar are constants from the table 207A.9-1, and the V is, of course, our basic wind speed in meters per second. Okay. Now, based on the table 207A.9-1, our V bar is 0.45 and alpha bar is 1/4. Okay? Now, solving for the V sub bar or V sub Z bar, substituting in the equation, we have 0.45 times 14.7 over 10 raised to 1/4, which is the value of our alpha bar, times 69.4, which is our V in meters per second. So, ilan ito? Sige, mamaya ko na anin. Isa na lang yung sasagot for the value of V sub bar and yung value ng ating NI. Okay. Now, yung NI, or N sub I natin is N sub 1 times L over Z bar over V sub Z bar, which is 0.952 times 110.906 over kung ano yung magiging value ng ating V sub bar. So, ano muna yung value ng ating V sub Z bar? Miss Adorna?
34.388 po.
34.38?
Opo.
Okay. Add natin ng isa pang significant figure. Okay. Then, ano yung value ng ating NI? Meron na tayong nakuha value for the V.
3.07 po.
3.07. Okay. Now, so we can now compute for the value of our Rn. Okay, yung Rn natin will be 7.47 times, of course, the value of Ni, which is 3.07 over 1 plus 10.3 times 3.07 raised to 5 over 3. So, ilan ito? Mr. Gabinete. What is the value for our Rn?
Wait po, ma'am.
Okay.
$0.388 po, ma'am.
Sure ka na?
Opo.
One more. Paka-check.
Wait po, ma'am. $0.313, ma'am.
0.13.
313 po.
For a while. One more.
Zero point 338 ma'am. Ay, 338 po.
Sure ka na?
Po, ma'am.
Paki-verify yung, paki-check yung calculate mo. Baka may mali ka dyan.
Sige po, wait po. Ma'am, 0.0689 ma'am. Tama na po.
0.0689.
689 po.
So gawin natin 0.069, okay?
Sige po, ma'am.
Alright, so that's 0.069. Okay. So meron tayong value for our Rn. Now, while for RH, ang RH naman natin is 1 over mu minus 1 over 2 mu squared times 1 minus e raised to 2 mu for mu greater than 0. Okay? Yung RH natin is of course 1 for mu equals to 0. Okay? For the equation of u, you have 4.6 n sub 1 times h over v. Sorry, that's v bar sub z. Hindi siya v sub z bar. Okay? I stand it corrected. Stand corrected. So this is the equation of mu for RH, okay? So let me just write the equation number. For RH, this is the equation 207A.9-15A for the first and 19A for second. And this is for RH, RH is equal to 1 if the nu is equal to 0. That's from equation 207A.9-15B. And 19B for second. Okay? Now, let's now substitute. For the new, you have 4.6 0.0952 times 24.5 over 34.388. Mr. Ano, sino nga ba yung nag-recite kanina?
Ma'am.
Mr. Gabinete? So, anong value for our due? That's 4.6 times 0.952 times 24.5 over 34.388.
0.982 po ba yun, ma'am? Nakakulong sa open parenthesis po.
0.952.
Ay, 5 to po. 3.12 po, ma'am.
3.12.
12 po.
All right. So that's our value for new. So therefore, because nu is greater than 0, so ibig sabihin our RH is not equal to 1. So kailangan pa natin siyang i-solve. Therefore, use the equation RH equal to 1 over nu minus 1 over 2 nu raised to 2 times 1 minus e raised to negative 2 times nu. So we have here 1 over 3.12 minus 1 over 2 times 3.12 squared times 1 minus e raised to 2 times 3.12. Okay? So this would be 0.269. So meron na tayong value for our RH. Now, while for B or for R sub B, RB is equal to 1 minus nu minus 1 over nu minus 1 over 2 nu squared times 1 over e raised to negative 2 times nu for nu greater than 0. And of course, RB is equal to 1 for nu is equal to 0. So rewrite lang natin yung equation for nu. So this is 4.6 times N1 times B bar, because we're going to compute for the value of RB, so we're going to use B instead of H. Kanina H yung ginamit natin yung height. Okay, so we're going to use the value of B over V bar sub Z. So this is the equation for mu for RB. Okay? So solving for mu, substituting in the equation, we have mu equal to 4.6 times N1 yung N1 natin is 0.952 times 9.5, which is our B, over 34.388. Okay, so ilan ang value for our new Mr. Rodren, Mr. Ipil,
1.21 po, ma'am.
1.21. Paki-check na ulit.
Wait po.
Ma'am,
Oh,
yung value po ng B, hindi po 9.15.
value nung V.
Ano po, B.
B. Hindi
Opo.
ano?
9.15 po ata yun, ma'am.
Okay. Okay. Sige. Thank you. That's actually 9.15. Yeah, looking at the figure, 9.15 nga. So, thank you. So, this is $9.15. So, ilan yon, Mr.
1.165, ma'am. 165, ma'am.
165. So the value of our RB will be 1 over 1.165 minus 1 over 2 times 165 squared, quantity 1 minus E raised to 2 times 1.165. Ilan yun, Mr. Ipil?
Wait lang po, ma'am.
Alright.
0.5258, ma'am.
That's 0.52.
58 po.
So that's 0.525.
526.
525. Okay. Well, 6 na lang. Let's settle for
6
5.
na lang po, ma'am.
Oo.
0.526.
5 to 6. Okay. So we now have the value for our RB, no? So ang kukunin na lang natin is yung RL na lang, okay? Now while for RL, again, our RL is 1 over nu minus 1 over 2 nu squared times 1 minus e raised to 2 raised to negative 2 times nu 4. Also nu greater than 0. And again, RL is equal to 1 for nu if nu is equal to 0. Now, for our nu, for RL, that would be 15.4 times N1 over L over V bar sub C. So this is the equation of nu for RL. Okay? So ano ba yung L natin? Our L will be the horizontal dimension of the building or the structure parallel to the wind direction. Okay, so para dun sa ating building frame structure, no, yung L natin would be 2 meters. Okay, ito yon. So this one. So dahil parallel itong member na to sa wind direction, so dimension which is parallel to the wind direction, yun yung gagamitin nating value for our RL. Okay? So our RL or our L will be 2.0 meters. Now for our due, that's 15.4 times N1, which is 0.952 times 2 meters over 34.380. Okay? So, ilan ito? Mr. Fabian?
0.853 po.
So, that's 0.853. Okay? So, pwede na natin makuha yung value for our RL because our new is greater than 0. So, hindi equal to 1 ang ating value for RL. So, our RL will be from the equation 1 over nu minus 1 over 2 nu squared times 1 minus e raised to 2 or negative 2 times nu. So, this would be 1 over 0.853 minus 1 over 2 raised times 0.853 squared times 1 minus e raised to 2 times 0.853. So, ilan to, Mr. Fabian?
0.61 po.
Okay, so this is 0.61. So, nakuha na natin lahat ng variables or values ng ating each variable para sa formula ng ating R. Again, our R or the response resonant is R equal to this equation. So rewrite na lang natin. Now solving. And of course, and considering that B or beta is equal to 0.01. So yung value lang ng ating beta is just an assumed value for this particular problem. Okay, so rewrite natin yung ating equation for R. So again, R is equal to 1 over beta or square root of 1 over beta times Rn times RH times RB, quantity 0.53 plus 0.47 RL. So rewrite natin lahat or substitute natin lahat ng values to this equation. We have 1 over or the square root of 1 over 0.01 times yung RL natin, which is 0.069 times RH natin is 0.269. The RB is 0.526. Times 0.53 plus 0.47 times 0.61. So square root for that. Okay, the value for R is Miss Batul.
Ma'am, 0.89 po.
That's 0.89.
89 po.
Ano yung third significant figure?
2, ma'am. 892.
892. So, our value for R is 0.892. Okay? Or 893? 2 or 3?
Ay, 3 po pala, ma'am. Rounded off na pala. 0.893.
Okay, let's use 3 na lang, no? Kasi 9 yung susunod niyang value. So, that's 0.893. Okay. So, pwede na natin makuha yung ating value for our gas factor or GF. Okay? So, solving for GF, substituting GF is 0.925. Rewrite lang natin yung equation. We have 1 plus 1.7 I sub Z bar times the square root of G, small letter G squared sub Q times Q squared plus G sub R squared plus R squared times R squared over all over 1 plus 1.7 G sub V times I sub Z bar. Okay? So, rewrite lang natin yan. That's 0.925 times 1 plus 1.7, the value of our I sub Z bar. Ang ating I sub Z bar is again 0.281 square root of G sub Q squared, that's 3.4 times the value of Q, which is 8.878 plus G sub R squared, which is 4.178 squared times the value of R, which is 0.893, also squared. So square root for that over 1 plus 1.7 3.4 times the the value for our I sub z bar is 0.281. So ilan or what is the value for our gas factor or GF? Is Pactaw?
Ma'am, wait lang po.
Alright.
2, 4.7. 1.157 po.
1.157.
157.
Okay, verify natin. One point
1.157 po.
1.157 or 1.15160? Kasi 1596. Paki-check daw ulit. Tama. Sorry. My mistake. Tama na. It's 1.157. Okay, thank you, Miss Pactao. All right. So we already have the value for our gas factor, which is 1.157. Medyo mahaba yung computation for our gas factor. But we can now proceed, for the value of our velocity pressure. Okay? So step 6 is for our velocity pressure. Okay, so based on the exposure category B, kasi B yung ginamit natin, right? So based on the exposure category B of the Billboard structure, for a while. Tama. Exposure B yung ginamit natin. So based on the exposure category B of our Billboard structure, so yung ating velocity pressure coefficient KH or our KZ, will be, or we can determine that from table 207D.3-1 by interpolating. Okay, so we're going to interpolate the values for our velocity pressure exposure coefficient. So I'm just going to write this down para mas mabilis tayo, So this would be for our structure component. Our height Z, which is in meters, and of course the value for our KZ. So for our panel 1, yung panel 1 natin is 3 meters. So our KZ would be 0.572. For panel 2, The height is 6 meters. So our KZ would be 0.621. For panel 3, that's 9.0. Again, every bay kasi yung or every panel natin has a height of 3 meters, right? So nagkakaroon tayo ng increment of 3 meters for every panel. Okay. So for panel 3, we have 9 meters. So the value of KZ would be 0.697. For panel 4, we have 12 meters. So that's 0.757. Panel 5 is 15 meters. That's 0.807. Panel 6 is 18 meters. So that's 0.850. Panel 7 is 21 meters. Our KZ will be 0.888. And finally, or lastly, the panel 8 is above 24 meters. So our KZ would be 0.923. Again, the values for our KZ is from our interpolation from the table 207D.3-1. So hindi kasi not all values of the height is given at the table. So if we don't have the specific value for KZ, so we need to interpolate our value for our KZ. Okay? Now, meron na tayong values for KZ for every height or for every value of our Z based on the height of every panel, no? So we can now compute for the value of our velocity pressure QZ. Okay? The velocity pressure QZ is QZ equal to 0.613 times the KZ times KZT times KD times V squared. Okay? So for panel 1, because we have different values of KZ, uulit-ulitin natin yung pag-compute for our KZ because QZ because we have the different values of KZ. Iba-iba rin yung magiging values ng ating QZ. So QZ sub 1 is 0.613 times 0.572. That's the value of KZ at panel 1. 1.0 yung value ng ating KZT. The value of our KD, the directionality factor, which is 0.85. And our V is 69.4 squared. Okay? So this would be equal to ilan na lang ba yung natira? 3 na lang sila. So, hati-hatiin natin to. Kasi, for the remaining 3 na hindi pa nakapag-recite, tig 2 panel na yung sasagutan. Okay? Susulat ko na muna. Now, at panel 2, QZ2 is equal to 0.613 times 0.621 times 1.0 times 0.85 times 69 69.4 squared. At panel 3, QZ3 is 0.613 times 0.697 times 1.0 times 0.85 times 69.4 squared. At panel 4, QZ sub 4 is equal to 0.613 times 0.757 times 1.0 times 0.85 times 69.4 squared. At panel 5, QZ 5 is equal to 0.613 times 0.807 times 1.0 times 0.85 times 69.4 squared. At panel 6, we have QZ 6 equal to 0.613 times 0.0807 times 1.0 times 0.85 times 69.4 squared. Okay? So, yung remaining 3 na hindi pa nakapag-recite, so, tigdadalaw kayo yung una, 1 and 2, yung isa, 3 and 4, and last 5 and 6. Okay. So, yung magko-compute for panel 1 and 2, si Miss Inso. Sa 4 and 5, 3 and 4, si Mr. Villanueva. And lastly, si Miss Relatado.
Ma'am,
Hello?
yung value po ng KZ sa panel 6, same po sa panel 5.
Ay, ano ba yung nakasulat dun? Okay, sorry. That's 0.850. Okay. So, Miss Inso, what is the value for QZ at panel 1 and 2?
At panel 1 po, 1,435.471.
Oh, wait lang. 1,400 point
35.471.
471. For panel 2, we have
1,558.439.
point. Okay. Panel 3 and 4, Mr. Villanueva.
Ma'am, sa panel 3 po is 1,749.166.
166. Or 67. Round up.
67 po.
Okay, 167. And for 4,
Is 1,899.740.
all right. And lastly, Miss Relatado, for panel 5, we have
2,025.218 po.
2025
25.
point
218.
218. And for panel 6,
2,133.
2,133. Wala
Point
nang point
130 po.
130. Okay, so all of the Q or all of the values for Q has the unit of Newton per meter squared or kPa. Newton per meter squared, Newton meter squared, Newton meter squared, Newton meter squared. Okay, yung sa panel 7 and 8, sulat ko na lang ha. Then, hindi na natin isulat yung buong equation. So, at panel 7, UZ7 is 2,228.493 Newton per meter squared. And lastly, at panel 8, that's 2,316.328. Also Newton per meter squared. Okay? So now, we can now compute. Meron na tayong value for our... Okay lang ba extend tayo? Tapusin na natin yung yung solution. Okay, bale nasa last ano na to? Last value na. So, meron na tayong value for our QZ. So, pwede na nating makuha yung mismong design wind force F. Okay, so this is step 7. So, for our step 7, we can now compute for the design wind force F. Okay? So the design force is given by F equal to QZ times G times CF times AF. Of course, this is in Newton. So this is from the section D.4, particularly the equation 207D.4-1. Okay, so I will just rewrite the given variables for our QZ. Again, that's the value for our velocity, pressure. Our G is gas effect or GF, gas effect factor. Our AS is gross area of solid sign. The AF is the area projected. Normal to wind. And CF is force coefficient. From figure 207T.4-1. So we'll just consider, no, isang case na lang is-consider natin, no. Ang case na lang na consider natin is when the tarp is considered. So ibig sabihin, nakakabit pa yung tarpaulin dun sa ating billboard structure frame. Okay? So sulat natin. For our case, the tarp is to be considered. So yung tarp natin is nakakabit from panel 4 up to panel 8. Okay? So hanggang dito yung ating billboard. So ang billboard natin is from panel 4 up to the last panel, which is panel 8. Okay? So at panel 4, we have FZ sub 4. That's 1,899.741. Tama ba? O 740 times the value for our G is 1.157 times our CF is, based on the figure, that's 2.0, and the AF is 27.45. Okay? That's 3 times 915. Okay? So yung ang area projected by the wind is, for panel, is 3 times 915. 915 kasi yung ating width of the billboard structure, while the 3 meters is the height of every panel. So the area for every panel, considering with tarpaulin, is 27.45 square meter. Okay? So the value for our force, wind force at panel 4 is, ilan to? That's 120,670.155 Newton. Tama ba? Tama ba sa inyo?
Opo.
Okay. So sa panel 5 naman, our FZ sub 5, that's 2,000. 2,025.218. Tama ba? Okay. 218 times 1.157 times 2.0 times 27.45. That's 128,640.42 or 43 Newton. panel 6, our FZ sub 6 is 2,133.130 times 1.157 times 2.0 times 27.45. So that's 135,494.924 Newton. Okay? At panel 7, FC7 is 2,228.493. Same ba? Okay. Times 1.157 times 2.0 times 27.45. We have 141,552.315 Newton. And lastly, at panel 8, FZ8 is 2,316.328 times 1.157 times 2.0 times 27.45. That should be equal to 147,131.533 Newton. Okay? So summarize natin yung ating design wind forces, no? So panel 4, we have 120.67. Kinonvert ko na kaagad to kilonewton. For 5, we have 128.640 kilonewton. For 6, we have 135.494 kilonewton. For panel 7, 141.552 kilonewton. And lastly, for panel 8, that's 147.131 kilonewton. Okay, so this would be our design forces for every panel. Okay? So, saan ba mismo tatama yung ating wind force for every panel? Okay? Located ang ating wind force sa centroid ng ating panel. So, ibig sabihin, if we have a rectangular shape or rectangular area for our panel, dito, sa gitna, mag-a-act yung ating wind load. So, considering ito yung gitna natin, diyan tatama yung wind force natin for every panel. Okay? So, ibig sabihin, nandito, so, diyan tatama yung ating diyan tatama yung every wind forces natin sa centroid ng ating panel. Okay? So, for the value of FZ4 sa gitna ng panel 4, sa FC5, sa gitna ng panel 5, so on and so forth. Okay? Medyo mahaba lang, no? Mahaba lang yung ating computation for our wind load, but of course, we need to follow the provisions sa NSCP. Okay? My question? None?